Hello everyone, welcome to Cipher Space Scope. In this video, we are going to understand one of the most fundamental and powerful concepts in cybersecurity, that is cryptography. Now, whether you are sending a WhatsApp message, logging into your Gmail or making an online payment, the cryptography is working behind the scene. So in this video, we start from absolute basic and build a strong foundation step by step. Let me start with a simple question. What if cryptography doesn't exist? Imagine sending a message and anyone on the internet can read it. There would be no privacy at all. Now think about the online payment. Your banking details would be easily intercepted. This means no secure payment. Even worse, there would be no identity verification. Anyone could pretend to be you, your account, your identity, everything could be misused. And attacks would become extremely easy. Data theft, man-in-middle attacks, password stealing, everything become simple. So in one line, internet become completely insecure. So now, how do we solve this problem? The answer is cryptography. Cryptography is the science of securing information by converting it into a unreadable format. In simple terms, it takes a normal message and turns into a secret code. The main goal is very important: to ensure secure communication even when attackers are present. Now remember this key idea. The cryptography doesn't hide data, it hides its meaning. Before going deeper, let's understand some important terms. First, a plain text. This is an originally readable message, like a normal sentence. Next, cipher text. This is the encrypted version. It looks random and meaningless. Then we have the key. This is the secret value used during encryption and decryption. And finally, algorithm. This is mathematical method used to transform data. These four terms are foundations of cryptography. Now let's understand how encryption actually works. We start with plain text, the original message. Then we apply an encryption algorithm along with a key. This converts the message into cipher text. This cipher text looks completely meaningless. Then this encrypted data is transmitted over the internet. At the receiver side, the same key is used to decrypt the message back into plain text. So even if an attacker intercepts the data, they only see cipher text, which has no meaning without the key. The important part is, why is encryption is important? First, the confidentiality. Only authorized user can read the data. Second, data protection. The sensitive data like password and banking details are secured. Third, secure communication. The data travel safely over the internet. And finally, trust. The encryption builds trust in digital systems. So, we can clearly say the encryption is the backbone of digital security. Now let's talk about the most critical component, the secret key. A secret key is confidential value used to encrypt and decrypt data. First, it controls encryption. It decides how the data is transformed. Second, it enables decryption. Only the correct key can recover the original message. Third, it ensures security. Without the key, the data is useless. And finally, it defines strength. The larger the key, stronger the security. In fact, security depends more on the key than the algorithm. Now, let's understand encryption with a very simple classic example, the Cipher. This method are actually used by Julius Caesar to send secret message. Let's take a simple message. Hello. Now we choose a key. Here key is shift by 3. What does this mean? Each letter in the message will move 3 positions forward in alphabet. Let's do it step by step. First letter H. If H is moved 3 positions, it becomes K. E become H, L become O, and O become R. So after encryption, hello become KHOOR, which is completely meaningful. Yes. Now understand what just happened. We used a key, we applied a transformation, and we convert readable data into unreadable format. But the problem is this method is very weak. Why? Because there are only 25 possible shifts. So hacker can simply try all the possible values and easily break the message. But here the important insight, the modern cryptography work on the same idea. But instead of shifting letters, it uses extremely complex mathematical operation. Instead of 25 possibilities, there are millions and trillions of combinations. Let's move to types of cryptography. There are 2 main cryptography, asymmetric and symmetric cryptography. First, symmetric cryptography. Here, the same key is used for both encryption and decryption. That means the sender and receiver must share the same secret key. It is very fast and efficient. That's why it is used for encrypting large amount of data. But there is one major problem. How do you share this key securely? If the key is intercepted, the entire system breaks. Now, look into asymmetric cryptography. Here we use 2 keys, a public key and a private key. A public key is shared openly and a private key is kept secret. If someone wants to send you a message, they encrypt it using your public key and only you can decrypt it using your private key. This solves the key sharing problem, but it's slower compared to asymmetric encryption. So in real world system, the both symmetric and asymmetric works together. Now let's connect everything to real life. Cryptography is not just theory, it is used everywhere. First, messaging apps. Apps like WhatsApp, Signals, and uses end-to-end encryption. This means only the sender and the receiver can send message. Even the company can't read your message. Next, web security. When you use HTTPS in a website, this means your data is encrypted. Without HTTPS, anyone on the internet can read your data. Next, authentication system. When you log into Google or Apple, your password is protected using cryptographic techniques. And finally, online banking. Every transaction you make is secured using encryption. And so finally, the data remains safe and safe. So the truth is, you are using cryptography every second without even realizing it. Now comes a very important question. If cryptography is just math, why it is so hard to break? First reason, complex mathematics. Modern algorithms like AES and RSA uses advanced mathematical operations. Second, large key size. For example, a 256-bit key. This means there are 2 raised to power 256 possible combinations. That is unimaginably large number. Third, computational difficulty. Trying all possibility using brute force would take millions of years, even for powerful computers. And finally, these algorithms are carefully designed to resist attack. So remember this. Cryptography is not unbreakable in theory, but in practice it is extremely secure. So let's summarize what we learned. Cryptography secure communication. It to protect your data, your identity, and your transactions. It is the foundation of modern security. And remember this. Cryptography is not a magic. It is a powerful mathematics protecting your digital life. Thank you for watching the videos.